this video, we're going to continue working with confidence intervals. We want to know how to actually construct the confidence interval. So the first thing to do is find the value of the point estimate. In our particular case, the value of the point estimate is going to be our sample mean, our x bar. Then we want to find the critical value, that's z alpha divided by 2, which are those 1.96. The 1.44 that we found for the 85%. These are our critical values that we're talking about that go into our formula. We want to find the standard error, which is the standard deviation divided by the square root of n, and multiply it by our critical value to get our margin of error. Here's our margin of error. So whenever we want to actually construct the confidence interval, we add and we subtract the z times the standard deviation divided by the square root of n, our margin of error, from the sample mean. And we want to interpret our results. Notice it says using complete sentences. Please make sure that you are writing comprehensive, not just the confidence interval is. Pay attention to what you're working with, okay? So let's look at example 2. A professor wants to estimate how many hours per week her students study. A simple random sample of 78 students. So a simple random sample of 78 students, that's going to tell me that my n is 78. That's my sample size. Had a mean of 15.0 hours. So their mean for this sample was 15.0 hours of studying per week. We want to construct and interpret a 90% confidence interval for the mean number of hours a student studies per week. We want to assume that the population standard deviation, sigma, is 2.3 hours per week. Okay, so we have our n, we have our x bar, we have our sigma. We need our critical value that corresponds to 90%. Well, if I scroll back up to the critical values that we've already discussed, 90% is a 1.645. So we're going to use a z alpha divided by 2 is a 1.645. So let's find our margin of error first. That's going to be our z alpha divided by 2, our critical value, times our standard deviation divided by the square root of our sample size. So our margin of error is going to be 1.645 times 2.3 divided by the square root of 78. When we're calculating these, we want to make sure to round the margin of error, which is our m, to the same number of decimal places, as our mean, as our sample mean, as the sample mean. Because we've rounded the sample mean according to our data. So that means that as long as we keep our margin of error, we're still having that same rounding procedure, okay? So whenever I calculate this, 1.645 times 2.3 divided by the square root of 78, I don't want to round until the very end. Well, my mean has one decimal place, so I want to round my margin of error to 0.4. And our confidence interval says that we take x bar minus our margin of error, minus this entire thing, and that our population mean is between that and x bar plus our margin of error. So our margin of error is 0.4, and we're going to subtract that from our mean, sample mean of 15.0. And then we're going to add that to our sample mean of 15.0. Where if I take 15.0 minus 0.4, that's going to give me 14.6. And wherever I add it, it's going to give me 14.4. So this means that the professor can be 90% confident, because that's our confidence level, that the mean amount of time her students spend studying is between 14.6 and 15.4 hours per week. So again, the professor can be 90% confident that the mean amount of time that her students spend studying is between 14.6 and 15.4 hours per week. Sometimes we don't want to find just the confidence interval. Maybe we want to know how large of a sample must I have in order to get the margin of error that I want. In other words, I only want margin of error of, say, 2 points. Well, how large does my sample size need to be in that particular case? We use this in order to get our margin of error smaller. That's if we're willing to reduce the level of confidence. We can also look at the sample size and go from there. So let's look at our margin of error formula. Margin of error is z alpha divided by 2, that's our critical value, times our standard deviation divided by the square root of our sample size, n. But I want to know what sample size that I have. So the first thing that I need to do is I need to get this sample size out of my denominator. So I'm going to multiply both sides by the square root of n. When I do so, that eliminates it on the right side of the equation, leaving me now with our critical value times the standard deviation on the right side and the square root of n times our margin of error on the left side. Well, I still want to get that n by itself, so I'm going to divide both sides by our margin of error so that those two divide out. So on the left side now of my equation, I only have the square root of n is equal to my critical value times the standard deviation divided by the margin of error. Again, I'm still wanting to get this n by itself, that sample size. So what's the opposite of square root? Well, the opposite of square root is to square. So I'm going to square both sides. When I do so, that square root and the square cancel each other out, leaving me with n is equal to the critical value times the standard deviation divided by the margin of error, all of that squared. So you will notice that the square is on the outside of the parentheses. It means find out what's inside first and then square the entire thing. Let's look at example 3. When we have this, for a psychology experiment, Emma is assigned the task of finding the mean number of hours students sleep per night. Her results must be at a 99% confidence level with a maximum error of 0.25 hours. Assuming the standard deviation is 1.4 hours, how many students must Emma survey? So she only wants a margin of error of 0.25. We want a confidence level of 99%, so we've got a large confidence here. So we have a confidence level of 99%. Well, I'm going to scroll back up to where we had those common critical values. 99% uses a z-score of 2.576. So that means that our critical value, z, is 2.576. We want a maximum error, So our M is 0.25, and our standard deviation is 1.4. We want to find our sample size. So this is what we're looking for. So our sample size is our Z, alpha divided by 2, times our standard deviation, divided by that margin of error, all of that squared. So N is going to be equal to 2.576 times our standard deviation of 1.4 divided by the margin of error, 0.25, that amount squared. So in my calculator, I can do this multiplication and this division, and when I do, I get 14.4256. I still have to square it. I'm not done yet. I still have to square it. When I square it, I get 208.0979. This is a sample size. I'm looking at how many students do I need to survey. Can I survey as 0.0979 of a student? No, but this is the minimum amount that I can have. So let's come over to a number line real quick. If this is 208, this is 208.0979. I have to be at least here. Can I round it down to 208? No. If I round it down to 208, I'm not going to have the same margin of error. It's actually going to go down. So on sample size, we always want to round up to the next whole number, because I've got to be this far at least, and so I've got to go on to the next value. So Emma must survey 209 students. In order for her margin of error to be as small as she wants it with this large of a confidence interval. So I want you to practice some of these. We have only looked at where we have the population standard deviation. So practice a few of these, finding the confidence interval, finding the sample size, and in the next set of videos we'll look and see what happens whenever we don't have the population standard deviation. Maybe we only have a sample standard deviation. Let me know if you have any questions.